Hello everyone, good morning all of you. In our previous lecture, we have discussed about the Castigliano's first theorem and Castigliano's second theorem. In all that, we have discussed about the things that in any cases of determinate structure, we have to find out the deflection and the rotation, means slope, for a determinate structure using Castigliano's first theorem. In that case, we have discussed that whenever we want to find deflection, we have to take fictitious load P at that point where we want to find out deflection. And whenever we want to find out rotation, we have to take fictitious moment on that point for any determinate beam. We have also idea about the slope and deflection, and that we have studied in our previous subject, structural analysis 1. In that, we have studied different methods like double integration method, moment area method, Macculus method, conjugate beam method, and now today we are going to understand about the deflection of determinate beam using a next method, very important method, that is Castigliano's first theorem. So, dear student, for the understanding of this method, we have discussed in last lecture what we are going to do. So, for the detailed understanding, here I have taken one example. It will gives us the clear idea about the how to find out the slope and deflection using Castigliano's first theorem. So, what is the case? Find the slope and deflection at point B for a cantilever beam shown in the figure using Castigliano's first theorem, and take Ei is equal to 10 into 10 raised to 13 Newton into mm square. So, here this is our cantilever beam having UDL up to 4 meter length, 20 kilonewton per meter, and remaining C to B portion, that is 2 meter, and having 60 kilonewton load at the point B. It is our acting loads. Now, A to C portion having double moment of inertia, means it having 2 times flexural rigidity, right? And B to C portion having single flexural rigidity. Here, what we are going to find out? We have to find out the deflection at point B and slope at point B. So, for that, as per our criteria, we have to take P load on B point. So, how we will discuss and how we can understand here. Now, let's start. Consider 60 kilonewton load at B as a P, that we know. Here, for the finding out the deflection delta B, so we have to take a P load as a fictitious load at B. For the calculation, we must have to take Mx from right to left for the cantilever beam. As we know, whenever we are going to finding out the moment at X point for the cantilever beam, it must be from right to left, means reverse calculation must be done for the cantilever beam. So, why we are finding out the Mx over here? Because we have an equation for deflection, that is 1 upon Ei integration 0 to L mx into del mx upon del p into dx, and that we have discussed the equation in last lecture and we have proven that equation. Now for the putting the value in that equation, we must have to take segment of the cantilever beam. That segment is B to C and C to A, and origin for that B and C limit is 0 to 2 and 0 to 4. Mx for the that Mx is equal to P into X, and from C to A for the origin that minus P x plus 2 minus 20 x square by 2, that can be done. So we will finding the mx. Now del mx upon del p. So here del mx upon del p, that is minus x, and here minus 2 plus x. Now delta b is equal to 1 upon Ei integration 0 to L mx del mx upon del p into dx. We have to multiplication of that mx into del mx upon del p and integration of that with respect to x from the limit 0 to 2 and 0 to 4. So we will finding out over here that minus px into x and the multiplication of these all things. So we will get something like this. Right? Here integration is px cube upon 3 0 to 2 plus 1 upon 2 ei integration 0 to L means it is 0 to 4 and multiplication of these things. So we will get some equation like this, and the integration of these all things, that is 1 upon Ei px cube upon 3 integration is over. So it is limit 0 to 2 and 1 upon 2 Ei integration of these things, that is px cube upon 3 plus 4px square by 2 plus 4px plus 20x cube upon 3 plus 10x raised to 4 by 4, and the limit is 0 to 4. Now here what we have done, we have take 60 kilonewton as a P. So put the value of P as a 60 kilonewton in this equation and put the value of X that is given over here. Now from this we will get some values. Delta B is equal to 1 upon Ei, and the value after putting that value we will get 160, 1 upon 2 Ei, it is 960, 19, 20, 12, 18, 4, 26.67 and 640. Summation of this all is divided by 2. So we will get the delta B is equal to 2773.34. Now here we have to put the value of that Ei, and this is getting from kilonewton into meter. So we must have to convert this value in kilonewton into meter. So we will get Ei is equal to 10 into 10 raised to 4 kilonewton into meter square. So the delta B, which is 27.73 mm, which is downward. Now we have the value of delta B, and our next task, that is we have to find out that rotation at B. So for the rotation of B, we have to apply fictitious moment, that is M, clockwise at point B. So we will get something beam like this. For that we have to take again, make the table, that segment, origin, limit, mx, del mx upon del m, B to C, C to A, origin B, origin C, limit 0 to 2, 0 to 4, and mx over here, that minus m minus 16 to x, and over here minus m minus 16 to x plus 2 and 20x square by 2. So del mx upon del m, that is minus 1 and minus 1. Now for the rotation we have the multiplication of these two value, and integration that with respect to x with this limit we will get rotation, and the rotation is theta b is equal to 1 upon ei integration 0 to 2 minus mx minus 60x minus 1 dx plus 1 upon 2 ei integration 0 to 4 minus m minus 60 into x plus 2 minus 10x square into minus 1. So multiplication of these two we will get some value, that is theta b is equal to 1 upon ei integration 0 to 2 plus m plus 60x into tx plus 1 upon 2 ei integration 0 to 4 m plus 60x plus 120 and 10x square by 2. Now we have to put the value as a 0 because whenever we have to put that m, there is no moment, so the value of that moment is 0 over here. So after putting the value and integration we will get 1 upon ai 60x square by 2 plus 1 upon 2ai 60x square by 2 plus 120x and 10x cube by 3, and we have to put the limit over here. So after putting this we will get some value, that is theta b is equal to 1 upon ei 120 1 upon 2ei and something like this. We have the value of ei, and that is 10 into 10 raised to 4 kilonewton into meter square. After putting this value we will get the rotation at b, that is 0.00706 radian. So from this concept we are going to find the slope and deflection for the all kind of determinate beam. The concept is same. Whenever we want to find out the deflection we have to take p over there, and whenever we want to find out the rotation we have to take moment over that point. So we will get rotation and deflection at particular point. Now another case, determine delta b and delta c for a cantilever beam shown in the figure. So here we have to take deflection only at 2 points. There is no rotation, so no need to put any fictitious moment over any point. But here for the deflection we have to take two fictitious load at a 2 point for this beam. So here we have ei and the load, that is that point A, C and B, and here 3i and I loaded with UDL 30 kilonewton per meter. We have all the data. Now we know that for the deflection at B, applied fictitious load P over that point. Here no point load given, that P is equal to 0. So for the deflection at B we must have to make that table and finding out the mx from the origin. Here that we have written from B to x and from C to x, because this two is origin for us. Now what is the value in that table that given in over here? Segment, origin, limit, mx and del mx upon del p. This is the simple table. B to C and C to A, origin B and C, limit 0 to 3, 0 to 3, mx is equal to minus p into x minus 30x square by 2, that we know, and from C to A it is minus p into x plus 3 minus 90 x plus 1.5 minus 30 x square by 2, and over here whenever we are going to derivate this mx with respect to p we will get the minus x and minus x plus 3. Now we have the equation that delta b is equal to 1 upon a integration 0 to L mx del mx upon del p into dx. Now delta b is equal to, we have to multiply these two value and integrate that value with respect to given limit 0 to 3. So here 1 upon Ei integration 0 to 3 minus px minus 15x square into minus x dx plus 1 upon 3 Ei integration 0 to 3 minus px minus 3p minus 90x minus 135 minus 15x square into minus x minus 3 dx. Now, here we have to put the value p, that is 0 over here. So, term of that p is delete from here, and after that we have to integrate that things. So, we will get something like this. Okay, this is the part of mathematical step. So, we have clear idea about that thing, how integrate that and how put the limit over there. So, after putting this, we will get delta B is equal to 303.75 upon Ei for the first portion, and for second 1 upon 3i 810 1822.5 1215 303.75 plus 404. After putting the all and summation of that things divided by 3 Ei and over Ei here, we will get the deflection, that is delta B is equal to 18.22 mm downward. So, the first task is over here, that deflection at B. Now, next task, that is deflection at point C. So, for the understanding of that, the deflection at C, we must have to apply fictitious load P at C point. So, somewhere over here. And again here no point load, that's why I take value of that P is equal to 0. So, what we will get? Segment B to C, C to A, origin B, origin C, limit 0 to 3, 0 to 3, here 3i and I. Now mx, what is mx over here? 30x square by 2, but it is minus, and x from over here 30x square by 2 minus p into x minus 90 into x plus 1.5. So, differentiation of this mx with respect to p, we will get 0 over here and we will get minus x over here. Now, whenever this kind of thing, our calculation will be short for that. So, here multiplication of these two and integration of that with respect to x and with this limit. So, what we will get? Delta C is equal to 1 upon Ei integration 0 to L mx del mx upon del p into dx. Now, delta C is equal to 1 upon Ei integration 0 to 3 minus 15x square into 0, because del mx upon del p is 0 over here, and 1 upon 3 Ei integration 0 to 3 minus 15 x square minus px minus 90x minus 135 into minus x. So, after the multiplication of this, we will get 1 upon 3 I integration 0 to 3 15x cube plus 15 px square minus 90 x square plus 135x into dx. So, the delta C is equal to 1 upon 3 Ei, and the integration of these values, that is 15x raised to 4 by 4 plus px cube by 3 plus 19x cube by 3 plus 135x square by 2, and the limit, that is 0 to 3. Now, put the value p is 0 over here. So, the second term is 0. Now, put the value as x is equal to 3 over here. We will get 1 upon 3 I is equal to 303.75 plus 810 plus 607.5. So, our delta C is equal to 573.75 upon Ei. Now, we have the value of that Ei is equal to 10 into 10 raised to 4 kilonewton into meter square. We know about this. So, we will get the deflection at C, that is 5.74. So, we know that whenever the cantilever is deflect, the deflection must be maximum at free end. So at B point we will get the deflection, that is 18.22 that we have just finding before, and at C it is 5.74. So at B it is maximum and at C it is somewhere 5.74. So from this procedure we can get the slope and deflection for the cantilever beam for fictitious load and fictitious moment that we have understand. Now the first determinate beam is completed over here. Now in the next lecture we are going to discuss about the another determinate beam, that is simply supported beam and overhang beam. We will discuss in our next lecture. So dear student, this is the most important method for the finding out the slope and deflection, and this concept is used in Castigliano's second theorem, and we will find analyze the indeterminate beam with the help of Castigliano's first theorem. So this method is most important for us. Now thank you. We will discuss the next important things in our next lecture. Till then you just practice it, because mathematical steps are already done by you in previous subjects and you know about the integration. It is very much difficult for D2D students. So for D2D students, the practice for this mathematical step for this method is very much important. So I request all the D2D students, you have to do practice for this integration and differentiation, because it is very much difficult for you. But this chapter is very much simple, so you can understand about this. Thank you. Yeah, we'll meet later on.